Hello, everyone. I'm here today creating a video for you that'll cover some of the basic skills we need to start off the semester. I had received some messages, so I wanted to start off here and get this video out for you. So let's jump into it. As you see here in this video, we're going to discuss simplifying expressions and solving equations that are linear. I have a few problems for us to work out here on this first slide, as you'll see. The first problem here, I want us to evaluate, all right? One thing that you need to see here is we have different operations going on. And anytime we have a combination, some numbers and operations, we're dealing with an expression, all right? This expression doesn't have any variables, so we're going to be able to evaluate it to a single value. So what we want to do is use our order of operations. So make sure you have some way to remember the order of operations, such as PEMDAS or please excuse my dear Aunt Sally. Those are great ways to remember the order of operations. As you'll see here, the place that we need to start is in the parentheses. So let's go ahead and do that. Then with the parentheses here, we have 3 minus 5. Okay, so doing that, we'll have 12 minus 7 times negative 2 squared. With that negative 2 squared, come on. With that negative 2 now simplified, we can move on to the next step where we can deal with the exponent. Right, so we have negative 2 squared, so negative 2 times negative 2 is going to be positive 4. From there, we can move to the next step, which is multiplication division. So we have negative 7 times 4, which is negative 28, which will leave us lastly with this subtraction of 12 minus 28, which is going to be negative 16. One thing you want to be careful of, especially when doing subtraction, is that, hey, we can do 28 minus 12 to get to the 16, but we have to recognize the sign goes with that number here. If we look at 28 and 12 by themselves, 28 is bigger. So since we have subtraction of 28, our result needs to respect that. We're doing it that way. All right, so as we saw here, we started up here with this expression and we evaluated it to the value of negative 16. The next step is to bring in variables. As you see, I have two problems here where we have some variables now involved, but make sure you also see here the directions are also going to be different. All right. When I can get to a specific number, we're able to evaluate. But when we don't know a number, which is what a variable is, remember, variable is an unknown value, okay, all we can do is simplify. So what we're able to do with this is then look at this from the perspective of combining like terms. All right, so as we look at this problem, what we need to be able to do is say, hey, I have two terms with the variable x and one term that we're going to call the constant term, which is just the value negative 13. Here, make sure you see that this 5x means x plus itself 5 times. That's how multiplication works. Over here, x plus itself 3 times. So if we take a group of 5x's added together, sorry, let me roll 4, plus a group of 3x's added together, and I add both those groups together, we can just use our counting principles, which is nice. And we could say, hey, all we needed to do was 5 plus 3. So we're going to get 8. Now the key is to remember, keep the variable you're working with. So it should be 8x. And since the 13 was the only constant term we have, it just follows along. The next skill we need for simplifying is going to deal with what we call multiplication, or what we're going to call distribution. All right, so if we look at another example here and we talk about that multiplication, if I gave us 2 times x plus 3, that's two groups of x plus 3 added together. Hopefully what you see there then is that's going to be 2 x's and 2 3's. The distribution takes that to account and says, hey, we could just go ahead and do the multiplication rather than listing out a bunch of factors added together. So here, we're going to be able to multiply that 4 to both of the terms that are inside the parentheses. So we'll have 4 times 9 times 4 times the y. With that, we'll have 36 minus 4y. All right. Now, that's the foundational skills we need. The order of operations is something we're going to use all the time. And as far as simplifying, combining like terms and distribution is definitely something we need to be comfortable with. So let's look at some problems where we can practice it. So I have two more problems here. This first problem, right? We're dealing with variables, so that's why we're using the directions to simplify. So if we look inside the parentheses, we cannot add y and 2 together. They are not like terms. One is a variable term and one is a constant term. Right? We don't have any exponents, so we can go ahead and then move into the multiplication and division, which is where this -3 can then be distributed through our parentheses here. So we want to make sure to multiply that with both of those terms. And so we're going to bring down the 11y and then -3 times y and -3 times 2. So we have 11y minus 3y minus 6 now. Once we get here, though, we go back and see that, hopefully we can go back and see, I should say, we now have a pair of like terms that we can actually go do the subtraction we see there, right? So combining those two terms, we're going to have 11 and -3. So that'll give us 8y minus 6. Now, there is one thing that's going to be different with this second one. All right, we're still going to start off by distribution as we saw with the previous problem, but make sure you're careful here to recognize the thing that we're multiplying with in this first group has a variable itself. Okay, so just kind of write it in that expanded form again. We would have 2w times w plus 2w times 1 plus -3 times w plus -3 times 1. All right, so we have this in its expanded form just to make sure we highlight this, because what happens now is we have to watch out for this situation here when we have a number times itself. And again, we don't know the number. We want to use exponents. So we're going to write that as 2w squared. All right. So as we saw with like what we're going to call a coefficient back here, this is what we call a coefficient. That is repeated addition. Exponents will represent repeated multiplication. So we want to keep an eye out for that. Finishing out our multiplication though, we had our distribution, sorry. We had 2w times 1, -3 times w, and -3 times 1. But we're not done yet. Make sure you watch for your like terms. With this, though, make sure you understand that when you see this w squared, it is its own new term, right? So the exponent on a variable will make it different than a variable that doesn't have the exponent. So that 2w squared is going to be by itself. So 2 minus 3 will be -1, and we have our problem simplified. Now, what I hope is that this little video, right, can get us started. If you do have further questions about simplifying, please make sure you reach out to me or your instructor so we can help you out. All right. The next thing, though, I wanted to look at was solving linear equations. All right. And setting some of the foundational skills we need to solve equations. So as you look at these 4 problems here, I feel like they give a good representation of what to expect when it comes to the different skills needed to deal with equations. The one thing, though, I do want to highlight is make sure you notice that each of these has a symbol in there that we call an equal sign. Whereas all the previous examples, we did not have that. So as before I said those were expressions, now we're dealing with something that's going to compare two expressions, right, by placing them with an equal sign in between them, right? And that equal sign is going to be important because what we're saying is we want to determine if this is ever the same as this. So if we take this example here, you could probably look at it and be like, hey, we know that 10 minus 7 does equal 3, so that's great. But now we want to show our work that gives us something that we can have a strong conclusion to, right? So in algebra, what we're going to be able to do is say, hey, let's get this variable term by itself so that we have x equal to some number over here. And what that's allow us to do is once we get there, we could say that the only way to make this true is we plug in that number and it equals that same number. That would give us a true statement. that a specific number is the same as itself. To do that, though, we need two different skills. The first one I want to show you is what we call the addition property of equalities. And the way that I'm going to do that is I'm going to focus on that 7 there. And I'm going to add a 7 to both sides. Now, the reason I'm doing this is when I add 7 to both sides, I can come over here and say, hey, that now equals 0. All right. And the reason we like 0, though, is because now we have the statement x plus 0. And going back to our properties of real numbers, any number plus 0 is itself. On the other side, we have 3 plus 7, which goes back to the number I stated before of 10. Now here I did it with a constant term, but this equation, I want you to see you could also do it with a variable term. When you have a variable on both sides of your equal sign, it's going to be important to get it all to one side. So let's do this. Let's subtract this 2m from both sides. All right, the reason I'm subtracting again is I had 2m. When I do a subtraction of 2m, that's going to give me 0. That is our focus there. And then 0 plus 29 will give us just 29 over here. And then this subtraction, 3 minus 2, gives us just 1m. And we find that, hey, after I do that work, the solution that would make this equation true is 29. Now, it brings up an important part, that as we show our work, the reason it's important that we show our work is we're building an argument that has equivalent equations in it. They all share the same solution as we go through. So when I have the confidence to say the solution of this is 29, I could have plugged 29 in for both of those m's, and we would have gotten a true statement as well. And if you look here, this would have been 2 times 29 plus 1 more, which is what 3 times 29 is. Now, on these other side, though, we're dealing with multiplication instead of addition or subtraction. So we're going to have to introduce the multiplication property of equalities. Now, what happens here, the property that we want to focus on now is a number times something that gives me that number, right? We want it to be just z. We want it to be just y. Well, when you're dealing with that, we want to be multiplying by 1. Anything times 1 is itself. So as we look at this one, right now I have 7. So how do we make that 1? Well, if you have 7, right, we can multiply by its reciprocal to get 1. Another great way to write that is, hey, let's divide both sides by 7. Right? That way we have 7 divided by 7 here to give us 1, and 1 times z is just z. On the other side, we have 42 divided by 7, which happens to give us 6. Now, the reason I find it's important to show how the multiplication of a number and its reciprocal is equal to 1 is sometimes we're going to have fractions we're dealing with. So what we see here, we have 1/3 times y equals -4. Well, if you use the idea of a number times its reciprocal, that means then we can come over here and say, hey, let's multiply both sides by 3/1, which is just 3. Because then over here, this will give us the 1 we're looking for. And 1 times y is just y. On the other side, we'll have -4 times 3, which is -12. Now, as I mentioned, this represents just kind of the basic skills to get started with simplifying or solving equations, right? Please let me know if you have any further questions or concerns. And if you have another constructor, make sure you reach out to them. And I will do my best to post most videos in the future. Have a great day.